intermolecular forces. This is a little bit of chapter 11, and the reason why we include it here is because the type of polarity affects properties, because it affects the intermolecular forces that exist between molecules. So we know there are 3 different states of matter: gas, liquid, and solid. They're characterized by the arrangement of the particles. Most solids are crystalline, nice neat arrangement of particles. Particles still pretty close together in a liquid, but those attractions are not as great, and they can slip and slide around each other. And as far as gases go, of course, particles are much further apart. They move more randomly. Okay. So let's talk about why this is important. So whether or not something is a solid, liquid, or gas at any given moment depends on 2 opposing things. One of those is how much energy the particles have. The more energy they have, the more they can have energy to separate, but it also depends on the strength of the attraction between them. So energy allows these attractions between these particles to break, causing the phase change. Okay, so the more energy, the more likely the phase change is going to occur, but that phase change occurring depends on the strength of the particles' interaction between each other. So we call these forces between 2 molecules intermolecular forces, as opposed to this is an intra. The intramolecular force is the force of the bond, right? Hydrogen chloride bond. But these 2 hydrogen chlorides have an intermolecular force. Okay. In the intermolecular force, the attraction between 2 hydrogen chloride molecules is very weak compared to this bond, the bond that holds the molecule together. But they are strong enough to control some physical properties, and we'll talk about those. So any intermolecular force is known as a group as van der Waals forces, named after a scientist named van der Waal, right? Van der Waal forces are any intermolecular force. There are 3 types of van der Waal forces: dipole-dipole interactions, hydrogen bonding, and London dispersion forces. There's also a 4th type, which is called ion dipole, and it's important in solutions of ions. So if I have a sodium chloride solution, the water molecule, which is polar, has an interaction with the ions. Okay, but most of the time we're not talking about this ion dipole. We're talking about molecular attractions. Okay. So dipole-dipole interactions are molecules that have permanent dipoles. So if I have, let's say, HCl, right, it's got a permanent dipole, right? And if I have a bunch of these, they're going to be oriented so that the positive side of one is attracted to the negative side, more negative side of the other. Okay? So the positive end of one is attracted to the negative end of the other, and vice versa. And we often draw these lines as dotted lines, which means that they are intermolecular forces. Okay? So they're only important when the molecules are close to each other. So the greater the dipole moment in the molecule, the more polar the molecule, right? So as the dipole moment goes up, the boiling point also goes up. And that's because it's going to take more energy to break this attraction to allow this to go off as a gas.